If I look at these, when I'm solving a radical equation, I have to undo roots by using exponents. So for this one, I've got the square root. To undo doing the square root, I have to square each side. I've got to raise each side to the second power. Okay. What happens is the root and the exponent cancel each other out, so I'm left with a 2x. Over here, 4 to the second power is just 16. And now I solve what's left. I divide each side by 2, so I find out that x equals 8. And then the last thing I should always do with a problem like this, I should plug it back in and check it. So if I plug the 8 in, I have 2 times 8, which is 16. Square root of that is 4, so that works. Okay. You have to check for extraneous solutions here. Okay. So I just did a quick mental check, plugged it back in, and it worked. Number 18, again, we want to isolate the radical. We want to get it by itself. So I'm going to subtract the 5 from each side. So that's going to give me the cube root of x equals a negative 7. And now I raise each side to the third power to undo the third root, or the cube root. I raise each side to the third power. The root and the exponent cancel each other out. I'm left with x. Negative 7 to the third power is a negative 343. And then again, the last thing I should do here is double check this thing. So I plug it back in. The cube root of a negative 343 is a negative 7. And then negative 7 plus 5 is a negative 2. So that one works. Okay. So again, make sure you check for extraneous solutions. For this one, to undo the fourth root, I'm going to raise each side to the fourth power. So I raise each side to the fourth power. Over here, the root and the exponent cancel out. I'm left with 8x. Over here, negative 2 in parentheses to the fourth power is a 16. And now I divide each side by an 8. So I find out that x equals 2. I plug it back in just to make sure that it works. So I do 2 times the 8 is a 16. The fourth root of that is a positive 2. But I needed it to equal a negative 2. So it turns out that this value doesn't work when I plug it in. So x does not equal 2, which means the only solution I have didn't work. So my answer is no solution. Okay? In number 20, again, I've got to isolate the radical first. So I'm going to add the 2 to each side. I'm undoing the addition and subtraction. And then I would divide each side by the 2. I've got to get that radical by itself. I undo the multiplication. Now I can undo the root. To undo a square root, I have to square each side. So I raise each side to the second power. So I end up with 3x plus 1 equals 49. And now I just have a linear equation to solve. I'm going to bring this one up here. That's a 3x plus 1 equals 49. I subtract the 1 from each side. So I find out that 3x equals 48. I divide each side by the 3. So I find out that x equals 16. Okay? And the last thing I do is plug it back in and check it. 3 times 16 is a 48, plus 1 is a 49. Square root of that is 7. Times 2 is a 14, minus 2 is the 12, so that one works. Okay? You have to check for extraneous solutions. All right? If I look at the next one, I subtract the 6 from each side. So I find out that the square root of x minus 3, square root was a little long there, equals 2. And now I can undo the root by raising each side to the appropriate power. So I square each side. So it turns out that x minus 3 equals 4. I add the 3 to each side and find out that x equals 7. Again, the last thing I do, plug it back in. Just a quick mental check. 7 minus 3 is a 4. Square root of that is 2. Plus 6 is an 8. That one works. Okay? Make sure you check for extraneous solutions. If I take a look at number 22 right away, number 22, I have the absolute value equals a negative, which that should raise red flags. That should cause us to pause for a moment, because the absolute value can't equal a negative. So right away, I know this is no solution. Okay? And that's really all the further I should go with it. If I split it up and solve it, I do the 3x minus 4 equals a negative 1, and then the 3x minus 4 equals a positive 1. I could solve each of these. I add the 4 to each side, and then divide by the 3. Here I add the 4 to each side, and then divide by the 3. The two answers I get, neither one of them is going to be valid. Plug them back in, they don't work. Okay? 3 times 1 is a 3, minus 4 is a negative 1. Absolute value, that is a positive 1, so that one doesn't work. Plug the 5/3 in. 5/3 times 3 is a 5, minus 4 is a 1. Absolute value, that is 1, not a negative 1. So neither of those work. Even if you do split it up and solve it, you're going to find that each of these is an extraneous solution. It's no solution. And you should recognize that as soon as you see absolute value equals a negative. Okay? For this one, absolute value doesn't equal a negative this time, so it makes sense to proceed. So I've got 2x plus 5 equals a 3. I also do 2x plus 5 equals a negative 3. And now I solve each of these. So this one I subtract 5 from each side. So I've got 2x equals negative 2. That's an ugly looking negative 2. Almost forgot my sign in there. And now I divide each side by the 2. So I find out that x equals a negative 1. Okay. I do the same thing over here. I subtract the 5 from each side. So I find out that 2x equals a negative 8. I divide each side by 2. So I find out that x equals a negative 4. Okay? And plug it back in. Make sure they work. I plug the negative 1 back in. It gives me a negative 2 plus 5, which is a 3. Absolute value of that is 3. That works. The 4 back in. Negative 8 plus 5 is a negative 3. Absolute value of that is 3. Each of those works. Okay? So check for those extraneous solutions. For this one, I have to split this up into two inequalities. But before I even do that, remember an absolute value inequality is a compound inequality, which means it's either an and inequality or it's going to be an or inequality. All right? And this one, I look at it, I see the absolute value is less than, so less than, and this is an and inequality. Okay? So it's nice to label it to start. So I know it's going to be an and inequality. I'm going to write it as an and inequality. And I can think of it two ways. If I were to split this up, I'm going to put this in a thought bubble because this is not actually the way I'm going to solve it. If I were to split this up, one of the equations would be x minus 3 is less than or equal to a 4. The other one would be x minus 3 is greater than or equal to a negative 4. And really, if I rewrite that all as one inequality, I could write the negative 4, then the less than or equal to the x minus 3, and then the x minus 3 is less than or equal to the 4. Okay? And that's typically what I would do. I would go right to writing it as an and inequality this way, and now I can add the 3 to each side. And whatever I do to one side, I do to the other two sides. And that's going to give me a negative 1 is less than or equal to an x, less than or equal to a 7. And really, the only other thing that I should do here is check this to make sure there's overlap, to make sure that it's not no solution. And for this one, I want to be greater than this guy, which is going this way, less than this guy, which is going this way. So I have overlap in between. And that's what I'm looking for, which means this is a valid solution. Okay? If I take a look at number 25 is essentially the same thing, but this time the absolute value is greater than. So this one's going to be an or inequality. And I need to keep that in mind throughout this process. So now I still split this thing up. I split it into two inequalities. The negative 2x plus 4 is greater than or equal to 10. I also do the negative 2x plus 4 is less than or equal to a negative 10. Okay? So I start off the same way, and really since it's an or, I'm just going to solve each of these individually. I subtract the 4 from each side. So I've got a negative 2x is greater than or equal to a 6. I divide each side by a negative 2. And keep in mind, this is an inequality. So when I divide each side by the negative 2, I have to flip the inequality sign. So it's going to be less than or equal to a negative 3. And then I do the same thing over here. I subtract the 4. So I've got a negative 2x is less than or equal to a negative 14. I divide each side by a negative 2. Once again, this is an inequality. Since I have an inequality, whenever I divide by a negative, I have to flip the inequality sign. Okay? Again, this was an or, so I put the word or in between, and then I check it on the graph. I make sure that there's no overlap here. I've got the negative 3. I want to be less than that guy. I've got the positive 7. I want to be greater than or equal to that guy. So I can see that this looks like an or, and if it doesn't look like the or, it means either I made a mistake somewhere or I need to go back and tweak my answer. Okay? Number 26. So the store sells a 2-pound jar of peanuts for $6 and a 3-pound jar of cashews for $15. And they want to sell a 5-pound mixed jar for $17. How many pounds of each should they use? And the first hint that it gives us here is to find the cost per pound. So we want to find the cost per pound. And really, we need that for the peanuts and for the cashews. I don't need it for the mix, just because of the nature of the equations that I'll set up. So the peanuts, it's $6 for 2 pounds. So it's $3 per pound. I just divide the two. So that's $3 a pound. And that's important to note. The cashews, again, I divide. That's going to be $5 a pound. That was ugly. Let me try again. And now I can start to write some equations. I'm going to call the peanuts, the pounds of peanuts, x, and I'm going to call the pounds of cashews, y. Let me label those over here. So this is going to be x, this is going to be y. The first piece of information it gives me is the fact that we're going to mix 5 pounds worth. So if I do x plus y, that's going to equal 5 pounds. However many pounds of peanuts plus however many pounds of cashews is going to total 5. The other thing is the cost. And if I look at the cost for this thing, I want to sell that jar for $17. Well, it's $3 per pound of peanuts, so $3 times the number of pounds of peanuts, plus $5 times the number of pounds of cashews should equal my total cost, which is $17. Okay? So now what I have here is a system of equations. I'm going to take this second equation, or sorry, this first equation, and I'm going to solve it. I'm going to solve this by substitution. I'm going to solve this one for y, so I'm going to subtract the x from each side. So I've got y equals 5 minus x. And then I'm just going to plug that into the other equation. So 3x plus 5y, which is the 5 minus x, equals 17. And now I just need to solve. Okay? I've got a 3x. I distribute. That's a plus 25 minus 5x equals 17. I combine like terms. The 3x and the negative 5x. That's going to give me a negative 2x plus 25 equals 17. I don't know why I wrote a 12 like a crazy person. Let me section this guy off. So if I bring that up here to finish solving it, the negative 2x plus 25 equals 17. I subtract the 25 from each side. So I got negative 2x equals negative 8 divided by the negative 2. And now I finally have my, my pounds in terms of the peanuts. So there's 4 pounds of peanuts. I've got to plug that back in. And I can plug it in right here. And that we should be able to do in our heads, the 5 minus 4, which is a 1. Okay? So in other words, the peanuts, I don't know why I keep wanting to write an R there. The peanuts is 4 pounds. And the cashews is going to be 1 pound. Okay? Hope this was helpful, and good luck on your tests tomorrow.